Object-oriented programming in R. All right, so this is from our textbook by Hadley Wickham. And so we can, in R, you can create objects, okay? And there's a bit of a, so with objects, the thing about, so everything in R is an object, but you can also create classes of objects. And classes of objects will have certain attributes, and they will have the functions might behave in a certain way, or they might have special functions assigned to them. And when you have a special function that goes with an object, they're called methods. Okay, and classes are usually organized in a hierarchy. If a method does not exist for a child, then the parent's method is used, and the child inherits behavior from the parent. Okay, and there are a few different systems of object-oriented systems. I'd say the most common one is S3, and that's probably it. And it's very, if you've seen object-oriented programming in other languages, R's object-oriented system is very different from other languages. It's a legit way to have an object-oriented system, but it might feel very strange. Okay, and S3 is probably their most basic form, and the method call will be something such as you'll have the name of the function, and then you'll have a dot, and then the name of the object. Okay. And it's a very casual system. We don't formally define classes or anything like that. Was there a question there? No. Okay, you're just stretching. And S4, there's another system called S4. It's similar to S3, but it's a more formal system of object-oriented programming. And we'll talk about this on Friday. Today we'll focus just on S3. And so S4 has formal class definitions which describe the representation and inheritance for each class, and it also has multiple dispatch, which means that generic functions can pick methods based on the class, okay, not just one. And then we also have reference class, okay, and this is probably a little bit closer to other forms of object-oriented systems. They are mutable in that they are modified in place, whereas pretty much everything else in R doesn't work that way. If you want to modify something, you kind of overwrite it, and that's how you modify things, right? Like if you want to change the value in your state, you have to pretty much just overwrite it. You don't really modify in place, or you can subset and say, I want you to override this one thing in the thing there, whereas reference classes, they change in place. Okay, well, let's take a closer look. Before we get into S3, we'll also just talk about base types. These are the internal C-level types that underlie the other object-oriented systems. Base types are mostly manipulated using C code, but they're important to know about because they provide the building blocks for the other object-oriented systems. So, pretty much any function that you type into R, you can just type the name of the function and it will tell you how it's defined. Okay, with a few exceptions, and those are some of these primitive functions that exist written in either C code or Fortran code, and that's stuff we don't really see at all ever from the R interface. Okay, and so we'll talk about these things starting with the base types, and we'll take a deeper look at S3. There is Hadley wrote a package called Prior, which will give us tell us information about the object-oriented system that it belongs to. Okay, because as far as R goes, there aren't functions in the base set that say, oh, this is the function you want to use, or this is the object system that that we're using, or that it looks like here. Okay, so starting with base types. Okay, so underlying every R object is a C structure that defines how the object is stored in memory. The structure includes the contents of the object, the information needed for memory management, and also, and as far as this part goes, the type. Okay, and this is the base type for R. Base types are not really an object system because only the R core team can create new types. So we hardly ever add new things to the base types. Okay, so we've already covered a lot of the data structures, which cover the kind of the most common base types, those being the atomic vectors and lists. So atomic vectors and lists are base types. Okay, base types also encompass functions and environments, and also some more exotic objects like names, calls, and promises. Okay, and you can determine an object's base type with the function, and this is one of the functions that we've already seen, is type of. Okay, and unfortunately the names of the base types are not used consistently throughout R, and the type and the corresponding is function might use different names. So when we ask, what is a function, the base type will say is a closure, but then you don't ask R, is it a closure? You say, is it a function? Okay, so it's a little, it's not consistent, but the functions are called closures. Okay, but then there's a primitive function called sum. Okay, and that one's a built-in, and this is a primitive thing. So if you asked R, let me make my text bigger. Okay, so for example, a lot of, this is use method mean. Let me see. Standard deviation. This is a function that's written, and it will say, we're going to take the square root of the vector and things like this, and we can say, what is the type of for standard deviation? It'll say closure. Okay, but if you ask, what is sum? It's going to say it's a primitive here. Okay, and so if you say type of on sum, it'll say it's a built-in. So this is a primitive function here. Yeah, but then see, but you say is primitive, then you say sum. Okay. Is primitive SD? No. Okay. In case you need these details. And then we have mode and storage mode, but they're really just keep using type of. Okay, these are more so things from S, the precursor to R. Functions that behave differently for different base types are almost always written in C, and dispatch occurs using switch statements. Okay, so even if you never write C code, okay, it is good to know that we have S3 objects can be built on any base type, and S4 objects use a special base type, and reference class objects are a combination of S4 and environments. Okay, and so to see if an object is a pure base type, that means it's not S3, S4, or a reference class. You want to check that is.object returns false. Okay, so if I say is.object for SD, the standard deviation, this is just a plain old function. This is it's not an S3 object. This will return false. Okay. However, if I create a factor such as f, and I say factor, I'll just do take the letters as a factor. Okay. And if I say So we can ask type of for f, but then if I ask the class of f, it'll say it's a factor. And object, okay, the factor is an S3 object type, okay? So this will say it's an object. It's not a base type thing here, okay? Okay, so S3 is the simplest object-oriented system. It's the only object-oriented system used in the base and stats packages, and it's the most commonly used system in CRAN packages, okay? It's informal and ad hoc, but it works, okay? And so there's a little bit of elegance there. And if you were to take any part of it away, it would fail as a object-oriented system, okay? Now we don't, this is unfortunate, but we don't have a way to say, is it an S3 object type, okay? You could check and make sure that it is an object and that it's not an S4, okay? So we have a function that says, is it S4? Okay, so we can say is S4 for this factor f, and it will say false, okay? But if it is an object and it's true, then this will be the indicator that it's an S3 thing, okay? Now, but if I load up prior, the function prior, I can use the function otype on f. This is and it will say S3, okay? So object type is a function that exists within prior, and this will tell you that it's S3. But as far as without that library, there's not a direct way to see if something's an S3 object type. Okay. Okay. So so for example, a data frame here would be an S3 object type. Okay. Whereas if we ask the object type of X, okay, we do data frame $x. That's going to just be a numeric vector, right? And that's going to be a base type. Okay. Whereas when you create the data frame, the default behavior of the data frame is to take kind of these categorical or string variables as factors, and so the factor will be S3. Okay, and that's using the function otype in prior. All right, so far so good? Okay. And so in S3, methods belong to functions called generic functions, or generics for short, okay? In other object-oriented systems, you know, methods belong to objects or classes, okay? So if you've done programming and other thing, you'd have, you know, methods assigned to the class. Here, it's different, okay? The methods belong to the generic function. So to determine if a function is a generic, you can inspect its source code for a call to use method, okay? That's the function that figures out the correct method to call using the process of method dispatch, okay? And similar to otype prior, also has f for a function type, and we can ask here, okay? So for example, if I ask for the call to, if I ask what is mean, so normally to call the mean function, we say like mean 1 through 10, and we'll say, oh, that's 5, okay? But if we just say what is mean, and you just type that in, you'll see in here it says use method mean, okay? So mean counts as a generic function. If I ask for print without the parentheses, print is also a generic using this thing called use method print, okay? And this, it feels strange, okay? Well, and so what it's doing is that when you call mean on 1 through 10, it's taking these values 1 through 10, and then it's going to try to figure out what kind of object you've given it, and it will look up the appropriate mean function for the kind of object that you've given it. Okay. Oh, and then so if I used f-type on mean, it will say it's S3 and generic, and if I say f-type on print, same type of thing. Okay, so these would count as generic generic functions here. Okay, so some generics like the subsetting operator, sum, and cbind don't use method because they're implemented in C. Okay, instead they call the C functions using dispatch group or dispatch or evaluate. Functions that do method dispatch in C are called internal generics and are documented under this internal generic thing. Okay, and F-type knows about these as well. So if I could say, so if we look at sum, it looks like this, and F-type on sum, we'll say it's a primitive version of a generic here. Okay, so given a class, the job of an S3 generic is to call the correct method. Okay, so you can recognize S3 methods by their names, which look like generic.class. Okay, so for example, the date method for the mean generic is mean.date. Okay, and the factor method for print is print.factor. Okay, and this is the reason that so today, if you looked at style guides for R, they tell you don't use dot to put in between space names. Okay, so for example, you know, there's a function called t.test. Okay, if we were to write the function for t-test today, it would not be we would not want to use the dot here, but this exists, and we're not gonna complain about it. Okay, so because when it's written this way, it looks like this is a special method for the T generic applied to the test class, if that makes sense. Okay, so for example, you know, when you look at print, it's written this way, and we have a print method special for factors. Okay, so that because when you print out a factor, and this is how it prints out a factor, because when you print out a factor, what it's going to say, it's going to type out the print out the values in the factor, but it also tells you that there's 26 levels, right? And so this is like the way it's supposed to display the factor here, and so when it gets the factor object and you just ask it to print it out, it's using the print.factor method. And so over here, if you have t.test, it appears like it's the T method for test objects. Okay, or if you have print.data.frame, we understand this as the print method for data frames, or is it the print.data method for frames? Okay, this is kind of being a little tedious here, but this is generally why we recommend against the use of dots in the place of spaces. Okay, and so we could ask, you know, what's the F-type for t.dataFrame? This understands that it's a method to transpose a data frame. Okay, so you could transpose a data frame using this t.dataFrame, whereas if you do t.test, it understands that this is a generic thing for the t-tests. Okay. Okay. You can see all the different methods that exist for mean. So we have mean.date, mean.default, mean.difftime, mean.posix, and stuff like this. Okay. We have methods for a t-test, and we have the default t-test, and we have a t-test for formulas. If I do something like the methods for print, there are 197. Huh? So when you so there's a lot of stuff happening kind of in secret in R that make your life a little bit easier. Okay, but so you know, when I say, like, when I do 1:10, what R is doing is it's creating an integer vector 1 through 10, right? And then because I didn't give it a command, it's gonna take the thing and the default thing is to print it out. Okay, and so when I do 1 through 10, it prints out 1 through 10. Now I could do the same thing and say print 1:10. Okay, but and a lot of these things, right? So like if I took empty cars here, okay, and I did summary empty cars, we're going to get this, and it prints out all of this. Now, how does it know to do this? Well, there is a special print.summary method, okay, on how things, or print.summary table. I don't, maybe it's print.summary table. Well, there's special commands called methods that are assigned to, this is how you're supposed to print out, like the summary for a linear model. Like if we created a linear model or a general linear model or analysis of variance object and ANOVA thing, and you ask it to summarize the thing and it prints it out in different ways, and there's all sorts of different ways to do this, okay? And so we have all of these different print methods. And so methods are special versions of the function. Okay, we have your generic or your default print method, and we are creating special versions of them. Okay. So you can also list all the generics that have a method for a given class. So you could say methods for the class TS for a time series. Okay. We could see, are there special methods for the class factor? Okay. And we have a bunch of methods, special versions of each of these functions that apply just for the factor object. Okay, so here we can create our own classes and objects here. So let's say we wanted to just create this stupid thing called foo, okay, class foo, and we can define this using the command structure. Okay, and we can say, structure, and here we're going to give it a list, and all we do is we just say class is foo. Okay, or you could do it this way. You could create object foo and say foo is a list, and then you modify the class attribute. You say class of foo is going to be foo. Okay, and this, boom, now you have an S3 object type. As soon as you assign a class, it's now an S3 object type. Okay, like we didn't have to do anything special. It just kind of goes on the fly. You just say, all right, let's change the class of this thing and make it class foo. Okay, and then so a lot of times S3 objects are usually built on top of lists, or they're atomic vectors with some attributes. Okay, but you can also turn functions into S3 objects and other things as well, and you can also have them inherit from other classes as well. Okay, so you can say, it inherits from another class. Okay, and then the class themselves, the classes could be a vector of other classes. So for example, the class of the GLM object is class GLM and then LM, meaning it's going to look up, so GLM would be like a generalized linear model, and then LM would be a linear model. Okay, so if you take 100C, that talks about GLMs. And so when you create GLMs in R, you have a bunch of functions or methods assigned to the class of GLM. Okay, but then what it will do is that if it doesn't find a specific method for class GLM, it's going to say, okay, well, now I'm going to look for methods for LM, because a lot of times the methods for LM will also work for GLM object. Okay, and then if it doesn't find anything for GLM or LM, then it's going to use the default method. So you can create a vector of kind of how the methods should be found. Okay, And a lot of times when you create a new class, you'll have a constructor function, okay? It's kind of like when you want to turn something into a factor, there is a function called factor, which acts as a constructor. Whatever you put inside this function factor, it turns it into an object of class factor, okay? Or you have the data frame function. Whatever you put inside data frame, it turns it into an object of class data frame. All right, and so here we can create a function called foo as the constructor function, so that whatever we put in foo, in this case we want to make sure the x that we're putting into foo is a numeric vector, and all we're going to do is we're going to create a list of that thing and assign it the class foo. All right, so this is a very basic way to create a constructor function. That this constructor function, all it does is just check to make sure that x is numeric, and then it says, okay, we're going to create a list with that x stuff, and then we're going to give it the class foo. Okay, whereas factor, it's a little bit more complicated. You give it stuff and it figures out the levels and all of that, but it gives it the class factor here. Okay, now so S3 though, the object-oriented system, has no check to make sure that everything is correct. Okay, so for example, we can create a linear model, right? So this is probably so if you've taken 101A, this should be familiar. We're just saying linear model, and we're going to just relate the log of miles per gallon to the log of, I don't know what displacement is, okay, engine size. Okay, and we're using the data from cars. Okay, and then so if I ask what is the class of mod, it's a class LM, okay? And when I type out mod, this is how it prints. This is because it's using the print method for the LM class object, okay? Because if we ask what is the type of for mod, it's a list, right? So we can turn it into a list, okay? So this is something silly. We could take the mod object, we can say class of mod from LM, let's turn it into class data frame. All right, this is highly not recommended, okay? And now if I want to print this out, it's going to try to print it as a data frame, and it says I've got 0 rows here, but we've got these things here, okay? I can just do class of mod as a list, and now when I print out the model as a list, it looks kind of more like the traditional list structure that we're accustomed to seeing. Okay, and these are all the different values that are stored in there. Okay, but of course it really is an LM object, so I should turn it back, and then when we print it, it does this. Okay, and then we can ask for summary of this, and it prints out the summary. But these are all just special methods assigned to the class LM. So all of these things, when we type it out, it's there. But there's no check to make sure it's correct. So you can just change the thing to a data frame, and it looks funny, but the data is still there. Okay, and so it says, this might feel weird, and it is a little weird, but there's nothing wrong with it. It just says, don't aim the gun at your foot, right? And so we won't have any problems here. Okay. You can create new methods and generics if you want. Okay, so to create a new generic function, you create a function that calls useMethod. Okay, and useMethod is kind of this mysterious thing. Hadley says useMethod uses black magic to find out for itself. So here we're going to create a function called f, and it uses method f. Okay, it's going to call the function useMethod f, And so this turns it into a generic. Okay, the fact that it's using use method is f. And so we are going to give f a special method, a method for if the class is A, what f.a returns is going to just return the string class A. This is a method of f that applies to class A. So here I'm going to create a new object. It's A is just an empty list with the class associated with A. We could say class is A. And now when I call function f on A, it runs this special method class A. And it returns this. Does that make sense? Yes? No? No. So, okay. So we have. So here. Let me. Here. I'll run. Let me just clear out my workspace here. Okay. So I'm creating a function called f. All right. What does f do? F does absolutely nothing. It just says use method of f. Okay. And then f.a. If I run this, all it does is if f.a runs, it's going to print out class A. That's all it does, okay? Because f.a just says it's a function of x. It doesn't even bother looking at x. It just is going to return class A. Okay, this is the dumbest function you can make. Yes?
We haven't defined the method of f.
We haven't. You're absolutely right. We don't have a default behavior for f. Okay, so if I call f by itself, it's going to say I have no idea what to do, right? It says I don't have a applicable method here, okay? But if I call f for method A, I mean the f method for class A type, it's going to print out class A, okay? And then so here all I'm doing is I'm creating an object call with a class of A. All right, maybe for clarity I'll just call this okay, and so BBB, this is it's an empty list and it has the class A here. That's all it is, okay? And so if I call f on BBB, what does it do? It runs this function. It doesn't run the f function itself, because when it calls f, it's going to say, oh, I have to figure out which method to use, and it's going to run the f.a function. Okay? Whereas if I tried to call f it by itself, it doesn't know what to do. Okay? Is that all right? Okay. We can create a special version of the mean function. Okay? In this case, we can say mean.a is not going to return anything but the letter A. All right? And so this would break our, whoops, not really break anything, but here I've created a special version of the mean function that applies only to functions or objects of class A. So I can call mean on BBB, and it runs its own special version of the function, which just prints back A. Is that kind of okay? Yes. Yeah, because mean itself has if we look up mean, the actual function for mean, it uses a use method, right? Because mean's a generic. We're gonna run out of time here. Okay, so you can do stuff. Let me just kind of fast forward. There's all sorts of generic things, and you can try to break things if you want. Okay, so let's revisit our tic-tac-toe thing. Okay. Yeah. All right. Okay. So in tic-tac-toe, you had this state, right? Okay, and this was how we kept track of the board. All right. And so what I can do is I can create something. I can take just so this would be a blank board where we have 9 NAs, and I'm going to give it the class TTT for tic-tac-toe. Okay, so I'm creating a new S3 object type called TTT, and this will be it for the tic-tac-toe board. Okay, and what I want to do, so here I'm going to create just a constructor thing. So here we're going to call this state, okay? And if I create if I run the state thing and call it new game is now a tic-tac-toe board, empty tic-tac-toe board of class type TTT. All right. And all right, and so this is my display function here. Okay. So this is how I'm gonna get the board to display. So, you know, you probably did different ways to program your display function. I just did a bunch of cats. I just said start off with an empty string, okay, and then go through each one. If I'm going to just create something called J, which goes through each thing. If it's NA, return as.character 1 through 9. Otherwise, return the state that I return whatever that thing is, right? The X or the O. Okay. And then if it's not divisible by 3, then cat J with a vertical bar. If it is divisible by 3 or 6, I mean, if it's 3 or 6, instead of the vertical bar, give it the new line with the horizontal bar. And then if it's anything else, which in this case would be a 9, give it a new line. Okay. And then so when I do display new game, it looks like this. Right? Is that okay? You guys are laughing. Huh? Your display code was a lot longer? Huh. You know, you'll get better. You'll get better, okay? When I started off, I was terrible too, okay? All right. So, all right. So I'm gonna get rid of that. I'm gonna get rid of the display function, and all I'm gonna do is I'm gonna just change the display function, and I'm just gonna rename it to print.ttt. Okay? This is the exact same function as before. It's just I'm going to do print.ttt. Okay? And what this means is that because print is a generic, it's going to use method, and when it identifies it, oh, this is class TTT, it's going to use this function to print it out. Okay? And so I don't have to keep calling display new state. It's when I give it a thing, right? The default thing that R does is it prints out the object, right? If you type in 5, it prints out 5. That's the default thing. So now whenever I print out a thing of class TTT, it's going to use this print method. Okay? And so now when I just type in new game, it prints out the board. Okay? If I change new game space 5 to an X, it's going to print out the board as this. Okay, I don't have to keep saying display the new game state, because here it is using the method dispatch to say use the method of print that applies to TTT functions. Okay? All right, so that's kind of the basics of object-oriented stuff in R.